All right, so this first question is really easy. What is meant by weak acid? Acid that partially ionizes in water. Next question, pK values are given. We know that a lower pK value makes it a stronger acid. So the question is, state the mathematical relationship between pKa and the acid dissociation constant. So that's again really simple. pKa is wherever you get the P word, that tells you the minus log of that thing. So pKa means minus log of Ka. With reference to acidity, explain the difference in pK value between acid 1 and acid 2. What does that mean? In terms of acidity, we just have to mention that this one is a stronger acid and that one is a weaker acid relatively. Compared to each other, 4.9 makes it a weaker acid and 4.8 makes a stronger acid. Similarly, 2.8 is the strongest acid in all of them. Can you tell me why that is?
Because it has chlorine in it.
So what does that chlorine do?
It acts as an electron withdrawing group.
Good. So it withdraws the electrons, reducing the charge density on the carb, the COO. And because of that, it makes the base, conjugate base, more stable. But that is why it's a relatively strong acid compared to the other ones. Okay. Okay. And that's the main idea in this whole chapter. Okay, dicarboxylic acid dissociate in stages. ठीक है, we have dicarboxylic acid middle में जो कुछ भी है, we don't care about it. Stage 1 में एक side से H positive lose हो रहा है, stage 2 में दूसरी side से H positive lose हो रहा है. The pK value for stages 1 and 2 are listed below. Okay. For comparison, the pK value of ethanoic acid is 4.76. ठीक है. So we can clearly see that for the first stage, all of them are stronger acids compared to ethanoic acid. But for the second stage, they're all weaker acids. Of course, it could do a lot with the availability of H positive already. Agar H positive ions already chale gaye hain, so the equilibrium is not going to like go forward with that much speed. Or uski wajah se losing the second H positive may be a little difficult. State the mathematical relation between this. अभी हमने बात की pKa will be minus log of Ka. Okay. We refer to the table above why pK1 values are smaller than the pK values of ethanoic acid. So first of all, they're saying कि बताएं जी क्यों carboxylic acid जो है वो उतना strong acid नहीं है जितने ये हैं खुद से. You can look at the acid. Why is it that when this loses H positive, it makes a conjugate base which is more stable? Is there something donating electrons? There is this whole chain. So there is an electron withdrawing. No, not electron withdrawing. Actually, electron donating effect in here. Okay. Get it?
Yes, sir.
No? Great. Why does it become larger as n increases? Why is it K when n increases, this pKa becomes like it becomes larger? Why is it that it becomes a weaker acid?
So your
ऐसा क्यों है?
conjugate bases are becoming weaker?
Sure, conjugate bases are becoming weaker. Are you sure? They're becoming weaker. So is that why they are driving the equilibrium backwards? Because देखो, the acid is becoming weaker. A 4.16 and 4.31 value shows that iska acid is becoming weaker. It doesn't lose H positive as strongly.
So doesn't that make the conjugate base weaker though?
No, it makes the conjugate base stronger. अगर एक weak acid होगा तो उसकी conjugate base strong होगी.
Oh, अच्छा ठीक है.
है ना? So why is it कि conjugate base strong हो रही है and it's getting the H positive and going back? Why is that the case? सोचें, in what situation is conjugate base weaker? When there is some withdrawing effect. कोई चीज इलेक्ट्रॉन विड्रॉ करिए यहां पे. Oh wait, when electron donating effect होता है. Because अगर इलेक्ट्रॉन डोनेट कर रहा है, नेगेटिव चार्ज becomes more concentrated, जिसकी वजह से H पॉजिटिव को जल्दी अट्रैक्ट करता है और उसकी वजह से वो बैकवर्ड जाता है. So if I have 3 CH2 groups, will they have a greater electron donating group? क्या हो गया? Obviously. Alkyl groups have a positive inductive effect. ऐसे ही है. That means they give electrons. So if you have CH2 here compared to 3 CH2s here, तो 3 CH2s का इफेक्ट ज्यादा होगा ना इलेक्ट्रॉन डोनेशन का. तो उनकी वजह से they will provide more electron here, which will concentrate the negative charge more, which will pull the H positive more, which will drive the equilibrium backwards. अगर आपको बिल्कुल समझ नहीं आ रही ना इसकी और आपको सोचना है कि क्या करना है, तो सोचो कि इलेक्ट्रॉन विड्रॉइंग ग्रुप और इलेक्ट्रॉन डोनेटिंग ग्रुप, बस इन दो को समझ लो. जब कोई चीज स्टेबल एनाइन बना रही है तो उसमें इलेक्ट्रॉन विड्रॉइंग ग्रुप होगा, क्योंकि स्टेबल एनाइन का मतलब ही है दैट द एनाइन इज नॉट गेटिंग अ स्ट्रॉन्ग इनफ नेगेटिव चार्ज टू गेट द H पॉजिटिव, सो द इक्विलिब्रियम इज टुवर्ड्स द फॉरवर्ड साइड. But if it is a less stable negative charge, so it is going to drive the equilibrium backwards. So वो कब होगा? जब negative charge more concentrated होगा. और वो कब होगा? When the alkyl group is giving a more inductive effect. So more या higher inductive effect of longer alkyl chain destabilizes the anion. ठीक है? That's the idea here. Okay. Suggest why all pKa2 values are larger than pKa values of ethanoic acid. मुझे एक बात बताएं, सिंपल सी बात है. आपके पास एक एनाइन है, आप उसमें से H पॉजिटिव निकाल सकते हो. Is it easy to do that? You have a negative charge and you want to drive it away from a positive charge. Is that easy? Is that something that is electrostatically good?
No.
No, it's not. So the simplest answer to this question would be that removing H positive from anion is not favorable. बहुत simple सी बात है. And that is why they are larger. That is why HSO4 does not lose H positive से इतना आसानी से. H2SO4 पहला H positive बड़ी जल्दी लूज करता है, दूसरा बड़ी मुश्किल से लूज करता है. This question we will skip it. Let's look at this. ये हम कर चुके हैं पहले. This one we have seen. The second one we have seen. Give the reasons for why pK value for chloroethanoic acid is smaller than that of ethanoic acid. That basically means that chloroethanoic acid is a stronger acid than simple ethanoic acid. And of course, the reason for that is that chlorine has electron withdrawing effect, which stabilizes the conjugate base, या जिसको हम anion भी बोल सकते हैं, anion. Okay, and that's it. You can also talk about CH3 has electron donating effect, destabilizing CH3COO minus. So in this case, the negative charge is more concentrated because the positive inductive effect of CH3. So it pulls on H positive more, drives the equilibrium back. In the case of chlorine, The chlorine pulls the electrons, reducing the concentration of negative charge here. So the equilibrium does not go back as easily.
Sir,
Clear?
in questions you always mention the alkyl group, right?
Yeah, because basically electron withdrawing or electron accepting groups, दोनों में से आपने देखना होता है.
Okay, thank you.
Using the Zwitter ionic structure, ये अभी हमने पढ़ा नहीं है, ये अभी हम छोड़ देते हैं. ये भी आसान है. We'll leave this out as well. Okay, let's look at this one. Describe and explain the relative acidities of these three. Okay, सबसे पहले what I'll do is I'll put the electron withdrawing या electron donating groups here. सबसे पहले, this one is going to pull on the electrons from the ring. This one will not be able to do that. Phenyl methanol इतने आसानी से pull नहीं कर सकेगा because oxygen is really far away. ठीक है? And the inductive effect it might get will probably be weak क्योंकि the ring is going to pull on the inductive effect of the carbon, not the O. ठीक है? So ring is going to pull on the electrons of CH2 more than the O can. And in this case, this one is going to give electrons to this. ठीक है? जिसकी वजह से oxide भी अपने electrons इसको दे देगा. So the ring को ज़्यादा electrons मिल जाएंगे. All right, so let's see. I personally think that this will be the strongest and this will be the weakest. So let's answer the question. क्यों explain करना है? Sorry, क्या लिखना है? We just have to talk about that. First of all, benzoic acid is strongest and phenyl methanol is weakest. And then we talk about the inductive effects that in benzoic acid, the electron donating, the ring is providing a positive inductive effect, which is, wait a minute, हमने acid की बात करनी थी. So, is this going to pull on the electrons? Or is this going to like, ring इसको electrons देगा या नहीं देगा? Yeah, that's right. यहाँ पर electrons इसको donate होंगे और नहीं होंगे बल्कि. क्या होगा यहाँ पर? We have to talk about the stability of the anion. So iska anion, the ring is going to pull on the electrons. But इसमें the ring is going to give the electrons. हाँ, that's the case. Because यहाँ पर CH2 अपना alkyl effect इसको देगा. I don't know what I was saying earlier. So now we know. ये थी reasoning है. So we'll say that in benzoic acid, the carbon provides positive inductive effect to ring, या benzene ring, that stabilizes the anion. And in phenyl methanol, the inductive effect of this carbon destabilizes the anion, which drives the equilibrium backwards. And in the case of this third one, because the methyl group is providing electrons, तो उसका impact इस O पे उतना ज़्यादा नहीं होता. We'll just describe it in our way. Okay, ester methyl phenyl benzoate is used in the manufacturing of perfume. So it's a two-step reaction for synthesis of this from 4-methyl phenol and benzoic acid. ठीक है. Not technically this chapter, but let's see. इससे हम कुछ सीख ही लेंगे. So first of all, मुझे एस्टर बनाना था, तो एस्टर तो obviously यहाँ से break down करना पड़ेगा. और ये वो चीज़ है जिसको मैं react करवाऊंगा 4-methyl phenol से. तो 4 methyl phenol तो ये ऊपर वाली चीज है. So it's gonna be this with CH3 here and OH here. So this is 4 methyl phenol. और दूसरे वाला benzoic acid है, यानी कि दूसरे वाला this thing. ठीक है. So 2-step reaction चाहिए. अब benzoic acid is not going to make esters right away. मतलब अगर ये होता ना एथेनोइक एसिड और कुछ और अल्कोहल, तो हाँ we would expect कि हाँ ये दोनों कर लेंगे. But phenol is not really going to act as a base. ठीक है, या phenol यहाँ पे H पॉजिटिव देके इसके OH के साथ नहीं करेगा कंडेंसेशन रिएक्शन. हमें कुछ और करना पड़ेगा. We will need a stronger something to take the H positive away. So we can displace, what we can do is कि पहले हम यहाँ से O की जगह पर ना OH है ना, इस OH को सब्स्टिट्यूट करते हैं. इसकी जगह हम कुछ लेके आते हैं, क्लोराइड ले आते हैं. Now this chloride will react with that. It can react with the phenol that you have. And now HCl will be made plus जो हमारा दूसरा product है. Okay? This whole thing.
Could you explain the first wala person?
So basically, the OH on the benzoic acid and the phenol, they don't react through esterification reaction. That is the first thing we need to know. हमने O levels में AS में पढ़ा था कि एस्टर्स बनते हैं और उनको बनने का हमने अल्कोहल्स और एथेनोइक एसिड से बनाते हुए हमने देखा था, अल्कोहल और कार्बोक्सिलिक एसिड से. But phenol and benzoic acid don't do that. It is possible to get condensation reaction going if we have a stronger nucleophile. OH की निस्बत क्लोराइड वगैरह हो तो ज्यादा बेहतर करता है इस रिएक्शन को. So that is why we replaced the OH with chloride. To do that हमारे पास different तरीके हैं. हम PCl5 से reaction करवा सकते हैं, PCl3 से करा सकते हैं, SOCl2 से करा सकते हैं. And that is how we replace OH with Cl. And once we have that, तो हमारे पास तीसरा, ये चीज, once we have that, we have acyl chloride. This acyl chloride will provide the chloride. It will get the H. It will form HCl, and it will get us the ester linkage that we are looking for. समझ आया?
Yes, sir.
Perfect. Let's try this. Minail, can you check with Iman? Where's she gone?
Sir, uska Wi-Fi नहीं चल रहा.
Oh, I thought it was just me.
No, she's just like trying to fix it abhi bhi, but like it's like you know how WhatsApp पे messages share जाते हैं, but like Zoom exactly नहीं चलता. So
Yeah, it
basically
happens.
that's happened to her abhi.
All right. Describe and explain the trend in acid strength illustrated by these values. Again, we can see that the one with chlorine, the one in the middle, it's the really strong acid. The one with 2 chloride, the one on the bottom, it's even stronger. And so we know that in the case of ethanoic acid, the first one, the alkyl group is providing a positive inductive effect. ठीक है, जिसकी वजह से the base becomes, or the anion becomes, less stable. But when you have one chlorine, it has an electron withdrawing effect, which stabilizes the anion. And when you have 2 chlorides, it stabilizes the anion more, making it a weaker base, and so a stronger acid. ठीक है. Calculate the pH, हम कर लेंगे. Calculate the pK value for this. pK value हमें Ka से बड़े आराम से निकाल लेंगे, माइनस लॉग से. और pH कैसे कैलकुलेट करते हैं? अगर भूल गए तो याद रखें कि pH कैलकुलेट करने के लिए यू नीड द Ka का एक्सप्रेशन. सो यू फर्स्ट नीड Ka का एक्सप्रेशन. फॉर एग्जांपल अगर मैं इसकी बात करूं, सो इट्स गोना बी CH2 प्लस H पॉजिटिव. इसमें डिवाइड होगा ना, तो इसका मतलब इनकी कॉन्सेंट्रेशंस को मल्टीप्लाई करना पड़ेगा ओवर the whole acid. CO2H. Yeah. तो इसकी concentration. Now we know है कोई information हमारे पास? We don't have any moles वगैरह. Oh, we do. 0.1 mole per dm cube. So Ka is 1.4 into 10 power minus 3. This is the same as this, so I'm going to write x squared, and this is 0.1. Cross multiply, and then it's pretty straightforward. H positive concentration आ जाएगी तो फिर minus log लगा देंगे. यहाँ पे हम डायरेक्ट pk minus log of Ka कर लेंगे, तो हमारे पास आंसर आ जाएगा. Okay, let's look over here. What's happening? We have a phenol and we are replacing the H positive here with Cl positive. So that is electrophilic substitution. And that happens because I need chlorine. And what type of reaction is this? Electrophilic substitution. Okay. And reaction 2. Reaction 2 में क्या हो रहा है? Reaction 2 में the OH is displaced by this whole thing, isn't it? No, just the H's. So the H is displaced by this whole thing. So H positive goes away. So obviously this whole thing obviously is a nucleophile. So this is nucleophilic substitution. क्योंकि यहाँ से H positive जाएगा और यहाँ पे CH2CO2H with a positive charge आएगा. Describe and test that would distinguish phenol from compound A. The difference in phenol and this is, yeah.
Won't the ऊपर वाला be negative? The
What will be negative?
CH2.
No. देखो, in the presence of chlorine, the electrons are going to give to that. So ये positive बनेगा और वो negative बनेगा.
So, but for nucleophilic, isn't the nucleophile like negative?
Oh, sorry, what's wrong with me? Yeah, you're right. तो फिर negative होना चाहिए. That is so weird. And I will achieve that because I have sodium hydroxide. Yes, sodium hydroxide will first make HCl, and that HCl will then react with sodium hydroxide. Yeah. So H positive. So यहाँ basically I think reaction इनका होना है, उसका नहीं होगा. Okay, here's what I think might have happened. First of all, this chlorine would have been displaced by this OH. That will make CH2OH CO2H. Then that OH reacted with this here, and that created water, and this whole thing reacted with that. Does that make sense?
Yeah,
so technically, this one displaced this, and that is why it is nucleophilic substitution. समझ आया?
Yep, makes sense. So basically जो CH2 CO2H और फिर वो OH जो NaOH से आया है, that's like the whole thing which is just being attached first position पे.
Yes.
Okay.
Describe a test that would distinguish phenol from compound A. ठीक है. Compound A में हमारे पास ये दूसरा alcohol है और ये phenol है. So how do they differ? We can use bromine, because अगर हम bromine लाते हैं तो phenol के साथ तो bromine add हो जाएगा, because bromine does not need a catalyst to react with phenol. right? Because OH provides electrons to the ring, makes it more reactive. And so the ring is able to react with Br2 right away. But in the presence of the other one, compound A, ring is not that activated. So उसकी वजह से यहाँ पर वो इतनी जल्दी ब्रोमीन रिएक्ट नहीं कर पाएगा. यू विल नीड अ कैटलिस्ट. तो खाली अगर मैं ब्रोमीन के साथ इसका रिएक्शन करता हूँ, सो यहाँ पर ब्रोमीन अटैच हो जाएगा, and that will give me a white solid. But no reaction here in the second one. Make sense? Because उसका withdrawing effect है, तो उसकी वजह से तो electron or the ring is even weaker. It's not going to react without getting a catalyst. ठीक है? All right. ये वही reaction repeat हो रहे हैं, ये questions repeat हो रहे हैं. Okay, let's see this. Structure formula for organic products of the following reaction. I have acyl chloride, COCl, and I'm reacting with this thing. So this and this react to make HCl. And so we will get this COCl will ester linkage बन जाएगी. ठीक है? Because H and Cl will react, the remaining will join together. यहाँ पर HCl बनना है दोबारा. So इसका एक H जाएगा और इसका Cl जाएगा. So you are going to get CONH Okay. So this is amide that we get. And hydrolysis कैसे होता है इसका? Again, HCl is made. Yes.
So why is it कि NH2 में से H जाता है, CH3 में से नहीं जाता?
Because the bond in NH is polar and the bond between carbon and hydrogen is not polar.
Oh, ठीक है.
So यहाँ पर we will get CO carboxylic acid बनना है ना? ये ना. Because the Cl and H join together और वो HCl बनाते हैं. तो तीनों में technically HCl बन रहा है. Condensation reaction हो रहा.
Sir, I'm so sorry, but इसकी position क्यों change हुई है?
Position change नहीं हुई, बस rotate करते हैं हमने molecule को. Draw करना आसान था. Position तो अभी भी सब में 1 पे ही है.
Got it.
बहुत पुराना सवाल है. Acyl chlorides are useful intermediates for making various acid derivatives. The following reaction scheme shows that. Okay. Let's see. यहाँ पे इसने क्या किया है? पहले उसने COOH से COCl बनाया. कैसे किया? OH की जगह पे Cl लेके आया. तो उसके लिए उसे चाहिए PCl5. वो कर सकता है. अच्छा. यहाँ पे क्या करेगा? This one is going to make HCl and then that is going to react. NaCl बनेगा. ठीक है. और यहाँ पर हमारे पास ester linkage बनेगी इन दोनों की. So yeah, I'm going to get OOCCH3. Make sense? Well, if this H, this Cl, and then they make sodium chloride and water. What's happening here? Ammonia add है. Ammonia आएगा तो amide linkage बनेगी. So I'm going to get CH3CONH2 because HCl is going to be made from this. ये मैंने बता दिया. Step 1, write an equation showing the reaction of phenol and NaOH and the reagents in step 2. Phenol और NaOH क्या बनेंगे? Sodium phenoxide बनाएंगे. So phenol is C6H5 5OH, yeah. And sodium hydroxide, they react, they make C6H5 O minus Na plus H2O, which obviously then moves on to whatever we needed. Draw the structure formula और JNK वो हमने बना ली. Clear? Question तो नहीं था उसमें?
No, sir.
All right. Phenacyl chloride has been used as a compound. It undergoes a nucleophilic substitution reaction with NaOH. ठीक है, nucleophilic substitution हो रही है तो OH is going to replace the chloride. So I'm going to get this whole thing, but OH here. And I'm going to get chloride separated. ये तो इस चैप्टर का क्वेश्चन नहीं है वैसे तो. Deduce the order. ठीक है, this is the previous chapter. Do you want to review it? या बस आगे चलें?
Sir, हमने rate of reaction किया आपके साथ?
Let me check. हमने एक चैप्टर छोड़ा था. Was it electrochemistry या rate of reaction?
I think हमने electro भी छोड़ा और हमने rate नहीं किया अभी.
लिखा हुआ है यहाँ पे, just a minute.
Or maybe we did do it.
Yeah. No, you're right. Wait, we did do rate. We didn't do electro. दोबारा कर लेंगे, उसको कोई इशू नहीं. दोबारा कर लेंगे अगर किया है तो. मुझे भी वैसे लग रहा है कि हमने नहीं किया.
I don't think so क्योंकि I remember क्योंकि मुझसे कि like order नहीं निकलता सही तरह. So I was like, oh, I'll ask you that. So I don't think we've done it अभी.
या ठीक है फिर नहीं किया होगा. हाँ मुझे याद आ गया, हमने एनालिटिकल स्टार्ट कर दिया था ना उसकी जगह पे. आपके एग्जाम थे या टेस्ट था कोई?
Yeah, we did that.
ठीक है. Describe the mechanism for the reaction that consistent with your overall equation. Which reaction? इस reaction में. ठीक है. So mechanism क्या होगा? We want to take the chloride out and we want to get the OH in. Will it be SN1 or will it be SN2? बताएं. Nucleophilic substitution हो रही है.
Yeah. एक minute.
SN1 or SN2? It's a primary carbon.
Sir, how do we know it's a primary? क्योंकि सर एक attached है इसके साथ.
Yes.
Oh, ठीक है तो फिर concentration उसकी कम है तो it's SN1.
What do you mean concentration कम है?
Didn't we do कि like वो 1 होता है SN1 तो उसकी concentration like compound की कम है?
नहीं, concentration of compound तो आप जो मर्जी कर दो. The concentration of compound affects the rate.
Oh,
The
अच्छा.
difference in SN1 and SN2 is the stability of the carbocation. Primary में the carbocation that will be made here will not be as stable. That is why it undergoes the SN1 mechanism, जहाँ पे उसे intermediate बनाना ही नहीं पड़ेगा. ठीक है?
Yep.
Sorry, SN2 करेगा ये. So मेरे पास ये कार्बन है, इसके साथ 2 हाइड्रोजन लगे हुए हैं, एक क्लोराइड लगा हुआ है, 2 हाइड्रोजन ऐसे दिखा देते हैं. Now the COH जो इसके पास आएगा वो इसको ऐसे अटैक करेगा. ठीक है? और यहाँ पर ऑलरेडी स्लाइटली पॉजिटिव स्लाइटली नेगेटिव चार्जेस हैं जिनकी वजह से इजीली अटैक हो सकता है. इसका नेगेटिव चार्ज है. अब अगले स्टेप में it's going to form.
Sir, this one isn't that stable, right? इसलिए SN2 हो रही है.
Yeah, it's not.
Okay.
Yes. And now this will make what we needed. Plus Cl minus, obviously. अच्छा, उसने बोला कि that is in line with the rate equation that you figured out. So obviously rate equation जो हम figure out करेंगे उसमें we will get the constitution of both of them, and that will be a big hint कि दोनों की constitution पर depend कर रहा है, तो ये SN2 है. ठीक है. Describe an experiment that will show that this reacts with water at a much faster rate than Acyl chloride. अच्छा, हाइड्रोलिसिस करना है हमने, तो इनफैक्ट हमने देखना है कि जल्दी रिएक्ट करता है, तो उसमें हमारे पास क्या होना चाहिए? फर्स्ट ऑफ ऑल वाटर इक्वल अमाउंट्स में होना चाहिए, इन दोनों की कॉन्सेंट्रेशन भी बराबर होनी चाहिए, सो मे बी टेक द सेम मोल्स ऑफ दीज, एंड हमें पता कैसे चलेगा कि रिएक्शन हो गया या नहीं हुआ? फॉर दैट वी हैव टू अंडरस्टैंड दैट with water the concentration will change because HCl is going to be made. तो जिसमें pH राइज करेगी दोनों में, सॉरी फॉल करेगी, एंड दैट pH एक खास वैल्यू तक हम कह लेते हैं कि जी जिस वैल्यू तक जल्दी पहुंचे या जिसमें जल्दी चेंज आए pH में, that is a more reactive substance than the other one. ठीक है. So COCl वाला ज़्यादा जल्दी रिएक्ट करेगा देन फेनेसाइल क्लोराइड. सो हमें टाइम देखना है, हमें देखना है पीएच कैसे चेंज हो रही है, और हमारे दो कंट्रोल वेरिएबल्स क्या हैं? द कॉन्सेंट्रेशन ऑफ दीज टू एंड द अमाउंट ऑफ वाटर. Suggest an explanation for this difference in reactivity. फेनेसाइल क्लोराइड हमारे पास ये है, और CH3COCl उसमें क्लोरीन डायरेक्टली कार्बन के साथ अटैच्ड है. ठीक है. So in this compound the bonding is like this. This is slightly negative, this is slightly negative, and this is slightly positive, but यहाँ पर ये भी pull कर रहा है, ये भी pull कर रहा है. In the case of फेनेसाइल क्लोराइड ये इसको pull कर रहा है, but ये directly इससे नहीं pull कर रहा. So clearly the slightly positive charge here is stronger than the slightly positive charge here. So इसकी वजह से I think कि इसको दो तरफ डाइपोल मोमेंट है, उसकी एक तरफ डाइपोल मोमेंट है, तो इसकी वजह से this reaction is slower than this one. All right then. Allah Hafiz.